Hello everyone! In this video we're gonna see the graphical representation. So the first one is a very easy one that you already know. It's called the pie charts. So to find the angle of each slice, it's really important to compute it using the percent. So what you do, for example, for the class 0, 10, you know the percent is 9.6%. So you multiply it by 360 degrees, and like this you will find the angle you need to use in order to sketch your pie chart. So very easy to read, very easy to construct as well. Another representation is the bar charts. It's something you also know. You can use it every time you have a discrete and quantitative variable or also a qualitative variable. So what you do, for example, the outcome, the value 1, you have it 5 times. So here you write 1 and you build your bar and you sketch it until you get 5 here. The value 2, you have it 9 times. So 2, you go till 9. The value 3, you have it 15 times. 3, you go till 15, and 4, 10, and so on and so on and so on. Just to let you know also that it's possible to sketch a bar chart using the percent. Instead of considering 5, 9, 15, 10, 6, and so on, you can consider 10%, 18%, 30%. So the value 1 would reach 10%, the value 2, 18%, and so on. The shape will be the same. An histogram, it's actually like a bar chart, but when you use a continuous quantitative variable. It's where actually the bar are side by side like this. But watch out, here it's a wrong histogram. Why? Because if we take this example here, we can see the class 0, 10 has 48 values. But the width of this class is 10. Compared to the other ones, it's different. So all the rectangles, we want them to have the same length, the same wide. So what we can say is, okay, I split my interval 0, 10 into 2 sub-intervals, and like this I get from 0 to 5 and from 5 to 10. And if I draw the bar till 48, then it's wrong, because I could think here I have 48 values here, 48 values there, so in total 96, but I only have 48. What I need to do is to make sure all my intervals have the same length. So the interval 0 to 10, I split it into 2, and also my frequency, I have to separate it. So I had 48 values, so it gives now 24 for the first one and 24 for the second one. The same for the interval 30, 40. I had 66 value, and now what I do is I split it into 2 same intervals and with 33 as a frequency. And that's how we get a correct histogram. The last graphical representation we're going to see together is a box plot. It's not really known around the world, but it's very, very useful. It gives a representation of the quartile, so Q1, Q2, and Q3, and also the extreme value. And it's very important because like this we can see about the symmetry of the distribution, if it's skewed or not. So what's here, it's the smallest value we have. What's there, it's the greatest one. So lowest one, greatest one. The beginning of the box is the first quartile. The end of the box is the third quartile, and finally we have a black line here, and it's the second quartile. which is the median actually. Let's see an example together. This box plot represents the grades obtained in the test. So we can deduce a lot of different things. We know that the worst grade is 2. We see it here. Worst grade is 2. And the best one is 6. As the beginning of the box is Q1, the first quartile, it means I have 25% of the data here. So it means that 25% of the students got a grade less or equal to 3. So I have 25% of the people here and 75% there. Knowing that the median is 4.5, I know that half of my students got a grade less or equal to 4.5. And on the other hand, 50% of my students had a grade greater or equal to 4.5. Q3 is 5.5, so I know that 75% of my students had a grade less than or equal to 5.5. And finally, as the beginning of my box is the Q1, so my 25%, and the end of my box is the Q3, so the 75%, it means in between I do have 50% of my data. So I know that 50% of my students are located in a range of 2.5, so because 5.5 minus 3. It's actually the interquartile range we saw in a previous video. With this famous example, we can also compute the quartile, first quartile, second quartile, third quartile, and then we can build the box plot. So the lowest value is 1, here the greatest one is 8, there, and then we write Q1, Q2, and Q3, and we have our box plot. We can see clearly in this example that the distribution is not really uniform. The values are closer to 1 than closer to 8.